All right, we're going to talk dilations today. Only one we haven't talked about. All right, and I save it for the end because one, it's not a rigid motion, and it's a little bit more involved than the other ones. I don't have little cool rules or anything to memorize like that. All right. So before we get into dilations, though, I did have a vocabulary term I wanted to throw at you, and that's called invariant points. So if you graph triangle ABC, we do something to it, and point A does not move anywhere. That's called an invariant point. Where after you perform a transformation, one or more of the points don't go anywhere. They just stay right where they are. All right, so official definition first. Points that do not change after a transformation. Right, points that do not change after a transformation. So they stay right where they are. C and C prime, A and A prime, same coordinates. So I'm going to challenge you right now, right off the bat in today's notes. We don't need to graph this at all. No need to graph it. I have quadrilateral ABCD. What I want to know is take point B first, point B, and give me a transformation, reflection, rotation, translation, that will result in B being invariant, meaning it's not going to go anywhere. It's going to stay 0, -3. Please know if one of you guys or girls do a translation of 0, 0 or a rotation of 360. We get it. It works all the time. Give me something more than that, though. All right, so 0, -3. Here you go, 0, -3. Give me a transformation and be specific that will result in B prime being right there. What could I do? I have all the ones. Serena, you want to take a shot? Nice job. Reflection, lowercase r over the y-axis. I like it. But since you guys are in what class here? Honors. I am going to ask for a second one, please. Please, no translations of 0, 0, rotation of 360, or rotated around point B. That would not move anywhere. Yes, I know. Anybody think they got another clever one? Come on, dig deep. Think you got one, David?
Yeah. A reflection over y equals -3.
Right? What about this line right there? Good work, good work. Reflection over y equals -3. Good work. All right, in your groups, what about point D? Give me a couple. Give me two. Give me two. I don't want a basic one either. Give me 2. 3, 0 stays 3, 0. Give me 2 in your group. Give me your 2. It's okay to talk. Got one here for me? All right, who's got one here? 15. How can I make it not go anywhere? Invariant. Darn right I could. Reflected over the x-axis. Going to stay right there. Anybody can come up with another one? Hopefully you did because I asked for 2. Jonathan?
Reflection over x equals 3.
Vertical line, x equals 3. That bad boy ain't going nowhere. Good. Good work. Good work, everyone. Any questions there? Invariant points. They go nowhere after the transformation. All right, you ready to sniff a little dilation here? I am. All right, I get it. Coming from middle school, when you hear the word dilation, you think something gets bigger, or maybe some of you think it gets smaller, or both, which happens. I want to go deeper, though, with you guys and tell you and show you why it gets bigger or why it gets smaller. All right. Rotations. Have you ever seen in the directions we always rotate around something, usually the origin, right? We rotate around something. Well, when we dilate, we always dilate around a point, which is called our center of dilation. All right, our center of dilation. And when a point gets dilated, I hate to break it to you, it doesn't get physically bigger, okay, or physically smaller. Here's what happens when you dilate a point. The point either gets further away from the center or it gets closer to the center. All right, that's what happens when you dilate a point. It gets further away from my center or it gets, in this case, closer to my center. So look at my first diagram in here. I had triangle ABC, and I'm doing a scale factor of 2, which means the following. Right now, let's just say from the center to A is 4 units long. That distance is 4 units. A scale factor of 2 says, hey, now I don't want you to get 4. I want you to double that distance away from the center. So I want you to go even further away and go how many units do you think? 8 units, correct. All right, so the scale factor is telling me how much further the point's going to get from the center or how much, in this case, ready, closer it's going to get. So here's a scale factor of 0.5 or 1/2. Let's say this distance right here is 12 units long. 12 units. I would like you to cut that distance in half. So make it come closer to the center. So what do you think this distance is from the center to A prime now? 6 units. That's why your figure gets bigger, because all the points are moving further away, or it gets smaller because all the points are getting closer together. How are you going to tell if it's going to get further away or closer? The scale factor will tell you. All right. So if I'm going to enlarge, make a figure bigger, anybody want to guess what I'm going to know about my scale factor? So here, instance, this figure got bigger because I had a scale factor of 2. What do you think I'm going to notice about the scale factor every time a figure gets bigger? Got a suggestion, Tammy?
Over 1.
Greater than 1, correct. So let's fill that in. A scale factor greater than 1 results in an enlargement. So anything bigger than 1 in a scale factor will say, hey, move these points further away, further away. And what do you think about a reduction? I know easy answer would be less than 1. No. Between 0 and 1. A scale factor between 0 and 1. There are such things as negative scale factors, but I won't, maybe we'll get into it sometime, but it's not necessary. All right, so greater than 1, hey, greater than 1, all the points further away from whatever the center is. Anything in between 0 and 1, I'm bringing those points closer to the center. All good, because we're going to move to, my focus today is not so much doing it with points, but with a line. Can a line get bigger or smaller? Heck no, it can't. So how do you still dilate a line if it can't get bigger or smaller? That's our goal today. All right. Here's my line AB. I want to dilate it through 0.0. So here's my center, everyone. Hey, here's my center, 0.0. Right, 0.0. So let's first assume, Claire, pick a scale factor bigger than 1 for me.
5.
5. Nobody do anything here. So say the scale factor is 5 here. So is point A going to get closer or further away? Closer or further away? Point A, closer or further away from O? Further away. 5 times further away than it is right now. Okay? So here's how it's going to look. And again, I am just guessing right here what's 5 times. I'm going to say it's right out here. Here's A prime. Does everyone see how it got further away? And we're just going to assume it's by 5. Point B, is it going to get further away or closer from O? Further away. 5 times further away, right? Actually, I shouldn't do black. Let me do green again. So here is B prime. Bless you.
Thank you.
And here is my line. Did my line change its size? No, it did not. Lines can't, right? They go on forever. All right, they don't change size or shape. But can you compare this to the original? Can you give me some kind of something they have in common? When I dilate a line, what still remains the same here? What's up, Lauren?
The angles.
What do you mean the angles?
Well, I mean,
Okay,
isn't it just an
keep
extension of
okay,
the line?
keep building on that. Keep building on that. I
Like
know where
the
you're
angle
going with.
measures?
What's that?
The angle measures.
Well, I just got a straight line though, so I don't really have angle measures. Are you talking like the way they're tilted?
Sure.
Okay, I'm looking for a vocab word then. Yes, she's right with the tilted part, but that means they are what to each other?
Parallel.
They remain parallel. Okay, so dilated lines. Here's the first little piece. All right, this one right here, it would remain parallel to the original. What's your deal?
Would the midpoint stay the same? Like,
What do you mean midpoint?
like of each line? Like,
Lines don't have midpoints. Segments do.
or-
Lines don't.
Okay.
Right? Okay. But here's the thing. We're going to be on the graph. Yes, the lines are parallel, but you know what's going to change? Slope won't change, but what's the other part of a line that we always worry about when we graph? Slope and y-intercept will change. Okay. The slope will remain the same. That's why they're parallel, but y-intercept will change. All right. So when you dilate a line, the resulting line will be parallel to the original. And I don't want to waste time doing this and drawing it, but let's say I had a scale factor of 1/2 now, and A and B got closer to O. Are they still going to be parallel? Yes, just different y-intercept. Okay, different y-intercept. Everyone all right on dilating a line? Because I got a little challenge for you now. What if the point on the center of dilation is on the line already? This one, it was off, so we saw what happens. What happens if the center is on the line? Mahmood, give me a scale factor bigger than 1. 2, fine, thank you. Thank you for not being obnoxious. Here, I'll go 80. Ready? Is point A going to get closer or further away? Scale factor 2. Further away. Where's A prime going to end up? Look at my diagram. Right now, I'm going to get twice as far away from point O. Where's A prime going to end up? Avery? Isn't point A prime going to end up on the line? Everyone agree? It's going. I don't know. Maybe right here. And where's B prime going to end up? On the line. What am I trying to tell you? If the center of dilation is on the line, what happens? Do I get a new line? Do I get a new line? No, the line remains the same one. Do we see that? Yes? Let me know here. When I do a scale factor of 2, that means whatever this distance here is going to double itself. All right, well, it's going to double itself in the same direction, which has to be on the line. So again, when I have my center on the line, it remains the same exact line. It remains the exact line. Only if the center of dilation is on the line I was given. All right, let's practice a lot here. A lot of practice today on the graphs. All right. I'll let you read through that one. Tie my shoe. All right, here we go. So it looks like I have line N is 3x plus 4y equals 20. Got it. I want a new line, line P. That's the image of this line. Ooh, scale factor of 1/3. Hey kids, are the points on this line going to get closer or further away from my center? Closer. Good. Closer to where? What's my center? 4, 2. Okay, so all the points on this line are going to get closer to 4, 2. Can you help me? Let's take a sneak peek at what this graph looks like, please. Can we take a little peek? I don't like graphing like that. I don't think you do either. You like y equals, right? A little help. Adjust it for me. First step. Can you get it into y equals so I can graph it cleanly? Yay, subtract 3x. I get 4y equals negative 3x plus 20. Next step, divide 4, divide 4. So if I put this into y equals form, it's looking like what? Y equals nice, negative 3/4 x. And it looks like, ooh, I can divide those plus. There we go. All right, now I can graph without my calculator. Hopefully you won't need it. What point can I graph first on there? 5 on the, which axis? Y-axis, y-intercept. Good. 1, 2, 3, 4, 5. There it is. Can I get 2 more points at least? How can I use negative 3/4 to find at least 2 more points? Where do I go from 5? Little help? Direction? Down. 1, 2, 3, and over. 1, 2, 3, 4. Down 3. 1, 2, 3. Over 1, 2, 3, 4. There's the line I'm going to dilate. We at least know this new line should be parallel, right? Anytime I dilate, it should be parallel, so it should have a slope of negative 3/4. But I don't know if anybody's catching on to this. What's the center of dilation again? 4, 2. Find it! Find it! Find it! 1, 2, 3, 4. Oh, where is the center of dilation? Oh, it's on the line. So no matter how far apart I pull them or how close together I put them, it doesn't matter. 1/3 or positive 3, it doesn't matter. What's going to happen to my new line? It'll be same exact line. So what is the equation now of my new line, line P? Line P? What's my equation? I'll take 2 versions. I'll take either version up here. Paul?
3x plus 4y equals 20.
3x plus 4y equals 20. If you guys wanted to put the y equals version we just did, fine. And then it does say explain, right? Yeah. Because, what do I know about the center of dilation? It's on the line. Because the center is on the line. There you go. Hopefully we're picking this up now. Doesn't matter how close I move it to 4, 2 or how far apart. That a resulting point will be somewhere on the line. Guys, all right. Going. Okay, we got to do still talk about what if it's not on the line, right? How do I find the equation if it's not on the line? All right. 3/2 x minus 4. Dilation of 3/4. Real quickly. Getting closer or further away from my center. Closer or further away? Closer. Good, because it's between 0 and 1. What's this line look like? Negative 4. 1, 2, 3, 4. Up 3/2. We look good. And speaking of our center, where is it? Where's our center of dilation for this one? At the origin. All right, everyone notice? It's not on the line. So I am going to have a new line, a new equation. I at least know what about this new equation, though. I know it's not the same line this time, but I at least know what. It should be, Paul? Should be parallel, which means what about their slopes? Same slopes. So whatever my new line is will have a slope of 3/2 as well. So goodbye, choice 1 and choice 2. Now, what's the y-intercept? Right? What's the y-intercept? Well, can I ask you guys right now? Let me call in a number here. What is the y-intercept right now of our line we're dilating? What's our y-intercept now? 8. What's our y-intercept? of the line we're dilating right now. This line that was given.
-4.
-4. Okay, answer me one more time. Is -4 going to get further away or closer to the origin? Closer. How much closer? 3/4 of the way closer. So how far is it right now away from the origin? How many units away is it right now from the origin? 4. It's got a distance of 4. And I want to take that 4 and say, all right, what's 3/4 of 4? Because I'm going to get that much closer. And if I do the quick math or on my calculator, 4 times 3/4, what distance do I end up with? 3. And what's 3 units from the origin? 1, 2, because I never go on the other side. 1, 2, there it is. There's that new point, 3/4 closer. So -3. So that's, I can just multiply with it. I know the slope stays the same, so the only thing I need to find is the new y-intercept. And I could just do that by multiplying the old one by the scale factor. Questions? Okay, I'm going to take a step back because we've done one of each now. You guys in your group, see what you can do with number 3. Okay, see what you can do. There should be no, I think there's no need to graph. That's why I didn't put a piece of graph paper there. I think you guys could handle this on your own. So I'm going to take y equals -3x plus 6, dilate it. You can at least eliminate 2 of the answers if you know you're dilating it. Scale factor of 2, center of 0.6. All right, what do we think here? -3x plus 6, scale factor of 2, so they're going to get further away. Further away from where? 0.6, but did anybody in your groups talk 0.6? What'd you notice about 0.6? It's on the line. 0. What's the y-intercept? 6. 0.6. Now, I understand. Some of you may not pick that up, that, oh, 0.6 is the y-intercept, so 6 is the y-intercept, so it's on the line. Ready? Here's how I'm going to show you how to do this algebraically, if your point is on the line or not without a graph. Are you ready? This point fits into this equation. Here's what I mean. What's the y-coordinate here?
6.
Does 6 equal -3? What's your x value? 0 plus 6. 6 on the left, and what do you guys get on the right? So if the point fits into the equation and works on both sides, it's on the line. All right, so you don't need a graph to do that anymore. So since it's on the line doesn't go anywhere, stays exactly the same. Questions from you? I don't think it's that bad, right? It's either on the line, it stays there, or I got to find the new y-intercept. All right, you guys can battle with Aaliyah here. Go ahead and battle with Aaliyah. 3 problems tonight. Come on. Getting soft. Was she correct? Aaliyah, was she correct? Is it the equation of my dilated line, negative 4/3 x plus 16? I don't think so, right? No. Why not? Tell me why not. Why is she incorrect? Because I think what she did was she saw the y-intercept 8, multiplied it by 2, because the scale factor was 2. You get 16, remained parallel, same slope. But why is she incorrect?
The point is on the line.
Points on the line, center's on the line. So what's that mean, Brennan?
The y-intercept stays the same.
Everything stays the same, including the equation of the line. Correct. So incorrect, Aaliyah. Sorry. Incorrect. The center is on the line, so the line would remain the same. All good with Aaliyah? All right, I think we'll have time for one more. I don't think we'll get to the last one. We can do that tomorrow after homework. All right, you got AB, 2, 3, 5, negative 1. What's the length of the prime one if I dilate AB by 1/2? What's up, Mahmood? Sorry.
Is that way that you showed us again to check the point is?
Yep. No, good question. So if let's say I didn't want to graph it, you could stick with you don't have to transform it, Mahmood. I could do 4x plus 3y equals 24. What's the center of dilation? 3, 4. What's the x coordinate? So I could do, does 4 times 3 plus 3 times, what's your x coordinate? Sorry. Yep. Sorry. Y coordinate. I messed that up. That should be 4y. 3y. Sorry. Let's try that again. What's your y coordinate? 4. Does that equal 24? 12 plus 12, I believe in my book, does equal 24. So it's on the line. If I got a different value over here on the left side, it would not be on the line. Okay. All right. So I got A, 2, 3, B, 5, negative 1. You're going to dilate it by 1/2. So right now, is this line getting smaller or bigger? This line set, it's not a line anymore. It's a line segment. Smaller. Line set, it's getting smaller. What's the length of it? What's the length of it? Well, how much smaller is it getting? Like say it's 10 units long. What's going to be the result then? If it's getting smaller by 1/2, so it would be 5, right? So what thoughts on this then? I know it's getting smaller by 1/2. Can you find out what's getting smaller by 1/2? Avery?
Could you use the distance?
Darn right, distance formula. So we can find the distance of AB and then cut it in half. Yep. So again, distance formula, x2 minus x1 squared plus y2 minus y1 squared. So find the distance of AB. And yeah, it's going to be getting small. The distance will be smaller. How much smaller? Half smaller. I learned the hard way. This time is not right. It's up there. Should end up be getting 2.5 at the end here, by the way. This distance should be 5, and you cut it in half, it should be 2.5. All right, 3 problems. That's all you got tonight. That's it, 3. There's not a need anymore for 3. Should get a distance of square root of 25, distance of 5, and then cut it in half for 2.5.
I prefer this kind of.
Have a good night, guys. Behave.
Thank you. Have a good day.
You too, everybody.
And then next one,
Yeah, I know you were. I saw you. You didn't see you.
that was fun. No, the honors rotation, honors reflections. Because the rotation was just a whole different thing. The rotation was like,
I have a lesson tomorrow during
Okay.
so should I just like watch the video?
Yeah, you can have your compass ready when you want to do some instructions.
Okay.
Ava,
Thank you.
you're welcome.
Tell your mom I don't care.